Hi guys, in this video we are going to talk about the characteristics of the mean and what happens when we mess with data points or mess with all the data points and things of that nature. So we're going to start off by saying that I gave a quiz, okay? You could score between 0 and 10 points, and the frequencies of the students that I gave this quiz to are as follows. And what we're going to do, just starting off, let's find the average of this quiz grade just as it is. So remember, to find the average from a distribution, we have to take the score, or the X value, that's the quiz score, and multiply it times the frequency. And then we're going to add all of those values up, as well as adding up the frequency. So starting off with just doing our multiplication, we get 20, 45, 8, 49, 0, 30, 12, 3, 8, 2, and 0. If we add all of those numbers up, that's going to give us 177. Remember, we also had to add up all the frequencies. There were 35 students in this class. So therefore, if we do our mean, we're going to take 177 divided by 35 and find out that our average is 5.1. So I want to kind of keep that in mind as we go through these problems and see what happens to our average as we manipulate our data scores. So our data score with no manipulation is the average for this class was a 5.1. So on the next one, let's say that we just wanted to change a couple of data points. Maybe we gave some late exams or we regraded something for some reason, okay? So let's say we had, instead of 4 zeros, we only had 2 because somebody retook it and they scored a 6. And somebody else retook it and they scored a 9. So notice that in addition to changing the frequency, I also had to change the F times X. So now for the score of 9, which had a frequency now has a frequency of 6, that score became 50, or that F times X became 54. And the same thing for the score of 6, which was 0, but now it's 1. So now I have 6 times 1, which would give me 6. Now, for the score of 0, you have a score of 0. So 0 times any number is still going to be 0. So 0 times 2 is going to maintain being 0. Now, one thing that didn't change on this was the number of students. I still have 35 students taking the test because I took 2 of them away from the 0, but I added 1 to the 6 and 1 to the 9 score. So I still have the same amount of students, but my F times X has changed. It's no longer 177. If I add all of those numbers up, they now add up to 192. So now if I find my mean with my new scores, I would have 192 divided by 35, and my average would now go up to 5.5, which makes sense because I had 4 zeros before, and 2 of those zeros have increased their scores, which would obviously increase my average. Now, if it had been the other way and scores had been deducted, then my average would have gone down. But there's no set amount it would have gone down because it just depends on how the scores are changing individually. So anytime we have just a single value or even 2 values changed like this, we have to recalculate the summation of F times X to find our mean again. There's no set way to determine how that's going to affect it. Now on the next slide, let's say we want to add or remove data points. We want to take them away altogether. So again, I'm back to my original scores here. I still have my 4 zeros down here at the bottom. We're looking at that. So a lot of times when instructors average a test, they don't like to average in the number of people who didn't take the test or scored a 0 because those zeros can hurt our average quite a bit. So what we'll do here is we're actually going to take all of those zeros away. So what's going to happen is, because it's 0, it's not going to change my F times X because that's going to stay 177. If I subtract 0 from 177, it's still 177. But what it is going to do is change my frequency. Since I am taking away 4 students, my frequency now becomes 31. So when I find my average now, I would have 177 divided by 31, brings my average up to a 5.7. Again, we can see that that average is increasing because I took away those scores that were 0. I took away those people who scored 0 or didn't attempt the quiz. So now let's say that I also want to see what happens if I take away the people who scored a 10 or a 100 here. So I'm going to take those away as well. Now, this time, not only is my frequency going to change, but so is my F times X, because I'm taking away 20 points. That's 2 times the 10 that they scored, right? 2 people scoring 10. So now I'm only going to have 29 people. Again, I'm taking away 2 people on my frequency, so I'm down to 29. And additionally, I'm taking away 20 points from my 177. So now I have 157 points divided by 29, which now gives me an average of 5.4. Okay, and notice that my average went kind of back to pretty close to what it was. It was 5.1 earlier, a little bit higher than the original because, again, I'm taking away those zeros. But notice it did drop from the 5.7 when I just took away the zeros because I took away people who scored very high. So a lot of times people will do that, again, when they're doing their average because they want to see what the class did. So we take away the low grades and we take away the highest grade and we average the center to kind of see what the vast majority of people scored. So now let's see what happens when we change the scores. Okay, so we're actually going to change the quiz scores. So notice I left my f of x off this time. We're going to start here. And what we're going to do is we are going to add 4 points onto every quiz score. Also notice that I'm using the data where I've taken out my zeros because I don't want to talk about them and I'm not going to add 4 points to somebody who did not take their exam. So we're going to leave those off. Notice my frequency is 31 again instead of the 35 of the number of students because I'm not going to talk about those 4 students. So we're going to compare this to our average of 5.7 that we found in the previous slide. So now let's take away those scores. And let's add 4 to every one. So my 10 becomes 14, 9 becomes 13, and so on and so forth. So now my lowest score that somebody could score was a 5. Okay, adding 4 points to every score. So now we're going to do the exact same thing we did on the very first slide. We're going to take our quiz score, we're going to multiply it times our frequency. So for the first one, we're going to do 14 times 2, which is going to give us 28. And we're going to go all the way down our entire rows that way. So we get 28, 65, 12, 77, 0, 54, 24, 7, 24, and 10. Again, in order to find our average, we're going to add up that last column, and that's going to be 301. So we're going to do 301 divided by 31. Okay, again, remember I took away those 4 students that did not complete the exam. So we get an average of 9.7. Now I want you to look at something. Remember, our average before we added the 4 points was 5.7. And our average after we added the 4 points is 9.7. So notice that there is an increase of 4 points from the original average to the new average where we added 4 points to every single score. Kind of cool. So let's say, again, that I have my test scores here. This time I don't want them as 10 points. I want to convert that into 100 and 90 and 80 and 70. So what I'm going to do is I'm going to multiply all of my quiz scores by the number 10 because that will put everything into hundreds, 90s, 80s. Okay? So let's get rid of those quiz scores and let's multiply them by 10. So we get the 100, 90, 80, 70 all the way down to a 10. Again, we need to make sure we multiply the quiz score times the frequency to get our last column there. So if we do 100 times 2, we get 200. And as we go down and do that multiplication, we get 450, 80, 490, 0, 300, 120, 30, 80, and 20. And again, we're going to take that last column and we're going to add that together to help get our mean. So we're going to take that 1,770 that column adds up to. Remember, we're going to divide by our frequency. Again, that's going to be 31 because we're ignoring those 4 students who made the 0. So we get 1,770 divided by 31, which gives us 57.1. Again, notice that the original score, and I went ahead and gave you an extra decimal there so you could see it, it was 5.71. But when we multiplied by 10 every single score, it became 57.1. So basically we took our original mean and multiplied it by 10. It's kind of a neat little process that happens when we do that for every single score on our exam, our test. So kind of in summary, if you change a single score or scores, it will change your sum of your x's, or if you're using a distribution table, your sum of your f times your x, your frequency times your x. But it will not change the number of data points that you have. It does not change your n. That will remain the same. And there's no real way to do a cool little prediction of how that's going to affect it. So you just have to do the math again and do your mean again in order to figure out what happens when you change a particular score. Let's say we add or subtract a score. So we're taking away scores this time. This is like we're taking away those students who scored a 0. This is going to change both your summation of your x's, not every time like we did with the zeros, but most of the time it's going to change your numerator, your sums of your x's or your sums of your frequencies times your x's. And it's going to change your n because you're taking away scores. You're not changing the numbers, you're actually removing them from your data set. So your n is going to either increase or decrease depending on if you're adding or subtracting data values. If we take and add to every single data point, you add the exact same number or subtract the exact same number. So like when we added 4 to everybody's quiz grade, that is going to change your original mean by however much you added or subtracted to each data point. So if you added 5 points to everybody's score, that's going to change your mean by 5 points. If you subtract 2 points from everybody's score, then that's going to change your mean by subtracting 2 points. So it's really cool that that does it, but you need to understand you have to do it to everybody's score in order for this to happen. Lastly, the same thing occurs when you multiply or divide by a number for every data point, for every score. So that was that when we multiplied everybody's score by 10. So instead of getting a 10, you got 100, or you got from going from a 9 to a 90. When we multiply everybody's score by the same number or divide everybody's score by our same number, then we can multiply or divide our original mean by whatever that number is. That means that I can, if I'm multiplying it by 5, I could take my original mean and multiply it by 5 and I would get my new one. Or if I'm taking my everybody's score and I'm dividing it in half, then I can take my original mean and I can divide that in half and that will give me my new mean. But again, it has to be consistent across all of your data points. You have to multiply by the same number. You have to divide by the same number. If you'd like any more examples of how these things work, please just let me know. I'll be more than willing to provide you with some extra examples.